so this is definitely special because we've had two essentially differential equation questions in one exam. It's kind of interesting. So they want me to write an equation for the line tangent to the curve at point 1, 1. So let's find dy dx at x equals 1, y equals 1. That's going to be 1 over 3 times 1 squared minus 1. Well, that's really 1 over 2. Okay, so the line tangent is y minus y1 equals m, or in other words, the slope at your point, which we just found out, over x minus x1. Let me just double check that I plug these in right. 1 over 3 minus 1. Oh crap, no, it's negative 1, 1. See, this is why you double check everything. Negative 1. That means x is negative 1. This is minus negative 1. So this is really 1/4. So this is 1/4. And this is positive 1 instead because it's minus negative. Okay. Double checking that now because I still don't trust myself. Y minus y1 and x minus x1. Okay. Now, you could also solve this for y. It's not really going to make a difference, because technically this is still an equation of a line. You can stop here, but wherever you want to stop. Okay, part B. Find all the coordinates where the line tangent to the point is vertical. So will be vertical if dy dx is undefined. Now, where's your slope going to be undefined, or where the denominator equals 0? Okay. Just thinking about what to do with this. Oh, okay. All right, so what does this mean? It means x equals 3y squared. Now, again, that's where so by substituting. So now what I'm going to do is I'm going to look at my original curve. Maybe I'll do it like this. Just say note. I don't know, I want to write this. So we have this. I just moved over the x to say, okay, notice that x is 3y squared. So y cubed minus xy equals 2. That's really y cubed minus 3y squared times y. I'm substituting that value of x into this equation. That equals 2. All right, so that means we're really looking at, well, this is y cubed minus 3y cubed. This is really negative 2. Y cubed equals 2. That's y cubed equals negative 1. And that's y equals negative 1. And so that's the y value where that occurs. And now let's figure this out. If y is negative 1, that also implies that x is 3 times negative 1 squared. I'm just going back to this. So x is 3. Okay, so the curve has a vertical tangent line at the point 3, negative 1. Again, that is where I should kind of explain what I did. I just kind of slammed through it, but you need to find first where, or the function that would make dy dx undefined, so where this is equal to 0. The big key there is realizing that you can substitute that into the original solution curve. In other words, you need to find a point on the curve itself. So you need to solve the actual curve using some substitution to know where your slope is impossible, to then find that particular point value. There could be more than one point, but because this was cubic, we only really ended up with one solution. Okay, so far this hasn't seemed too bad, and I spoke too soon, because now we have to find the second derivative. Oh wait, never mind, it's not as bad as I thought. Okay, but it is a quotient rule, but I just realized something that can make my life easier. Okay, so first let's just find this in general. That's going to be a chain rule. We're going to bring the bottom to the top. Oh, sorry, not chain rule, quotient rule. But the quotient rule kind of adds like a chain, whatever. So we bring the bottom to the top, derive the top, which is 1 dy dx, minus derive the bottom, which is going to be 6y dy dx, minus 1, because it's with respect to x, so that's safe, times keep y, all over, goodness, the bottom squared. Okay. So here's the good news. We don't have to do maybe as much work as you might be thinking, because you actually already know dy dx at -1, 1, because that's what we got up here. So let's substitute this in. It's really 3 times 1 squared minus -1 times 1/4 minus 6 times 1 times 1/4 minus 1 times 1. Oh, wait. Yep. All over the bottom squared. Okay, what's that? This, if you kind of remember, this was our denominator. It's where we got 4 from before. So this is really 4 times 1/4, which is just 1, minus, this is going to be 3/2 minus 1 times 1, all over 4 squared. So let's see here, 3/2 minus 1, this is really 1/2, so we have 1 minus 1/2. So we have 1/2 over 16, which is 1 over 32. I think. I don't know. It's early, and I want to go back to bed. So let's see how we did. Okay, we have our slope and equation of the tangent line. So yeah, they solved it for y. Again, you don't have to, but you might want to. Alright, so we set this equal to 0. You get the equation in one variable. Doesn't matter how you do that, but I think the easiest way is, yeah, doing what I did. That's what they did actually exactly. And then you get your 0.3 -1. And yeah, you do all your crazy substituting, and you get 1 over 32. Implicit differentiation, substitution for dy dx, and answer. So you get your point right by doing the quotient rule right and making sure you include the dy dx's. You actually get 2 points from that. So even if you get lost in plugging in all the values, just getting this right, which you should feel comfortable doing, gets you 2 out of 4 points, which is pretty good. Again, also, I think the fact that you get a point for just setting this equal to 0, knowing where a slope is undefined, that's a nice easy free point as well. And so is the first part. So, all right, we did it.